Hey YouTube, today we're going to build one of these 3x18 650 Smart PWM mods. It's not your average PWM or pulse width modulation board in here. The smart part of it, before we get to that, I added a switch on it here. Where in this mode, when the switch is up, it measures the approximate voltage on the output at the 510. In this mode, mod is on, but voltmeter isn't, seeing as how this won't be visible most of the time. No sense in it always illuminating the display there. And in the bottom mode, we're measuring battery voltage, so you can see how much charge you have left. And what makes this a smart PWM board, it has a bunch of built-in features. So you can set whether you're in lithium-ion or lithium polymer mode, but then it detects the amount of batteries based on the input voltage and sets an appropriate low voltage cutoff so you don't drain the batteries too low. There's no on-off, master on-off switch because if you hit the button 3 times fast, light flashes 4 times, mod is now off. Turn it back on, mod is now on. It also has a safety feature. If you throw this thing in your pocket and the fire button is pressed, there's a 10-second maximum. Have a look at the LED there. It'll blink. Mod's now in cutoff mode. Prevent some pocket fires. There's probably other features I'm forgetting about, but have a look at the website. All the list of the features are there. Oh, there's what they call a regulated mode. Normally as the batteries drain, you get less and less voltage. Full charge of a single 18650 is about 4.2 volt. When it's dead, you're around 3.2 volt. So as these drain, you're getting, or the amount of voltage goes down, and that would affect the output wattage. Between a full charge and drain batteries, the difference can be significant. So this thing has a regulated mode where if it's on, as the batteries drain, it modifies the width of the pulse to compensate, so you get an even or more consistent output wattage throughout the life of the battery, or the drain, the cycle, the charge cycle of the batteries. So much more than your average PWM board, the Smart PWM 2.2 in here. Stick around, we're gonna build this thing. First thing I'll wire is the battery sled. I'll start with the terminals that jumper strip and tin those real quick. I'll do them one side at a time because these are short, they're going to get hot. I'm going to open up that clip a little bit. I'm going to tin the inside of that. Tin the inside of those. Two. Now the remaining positive, I just want one wire coming off of it, and the remaining negative, want another wire coming off there. For the last positive here, I need 2 wires. One's going to the 510, and the other is for the positive voltage in on the board. One needs to be the heavy gauge, the other does not. So I'm going to strip these long. I'm going to tin this together. This negative down here is going to route under the sled to this channel. Throw a piece of tape over that, and we'll have our positive coming out here and our negative popping out there. Now for the board. I'm just going to run all my wires off of there, and we'll assemble it in the enclosure. The first through hole on the side here is our voltage in. So I'm tinning my wire, going through the hole, little flux on the opposite side. Next one over is for the switch. The other side of the switch is 2 over, so in the middle there is what's going to go in our wiper for the 10K pot. Now the other side of the switch. There's a tiny resistor there, be careful. The positive lead on the LED. On the wiring diagram, the next one over skipped. The other two here and down here are all ground. The negative leg of the LED is going to need to go to ground. The 0% on the pot's going to need to go to ground. So skip one. So those grounds are connected to the battery minus, the larger hole here. This one's the output to the 510 negative. To minimize the amount of wires that are coming off of this thing, the ground for the LED then, which is going to sit right beside the switch, right? The LED's here, the switch there. I might just jumper the negative lead off the LED onto the battery minus ground, which is going to the switch anyways, and save myself a wire tethering onto this thing. I'll wire the output to the 510 now. The battery minus, though, is this one coming off the sled. And I won't do it right now. I'll measure our lengths once we dry fit everything, then I'll cut and come solder this connection here. But for this one, I'll wire it, then we'll measure our length on this side, and I'll cut and solder it to the 510 negative. Next, I'll epoxy the trim resistor in. I think I want the 0 facing down. Imagine when I will be adjusting it, I'll be looking at it this way. So what I normally do is I'll dry fit it And I'll throw a piece of tape on there for two reasons. One, to make sure I'm super flush, and two, so it doesn't move around. And I don't want too much up top because our bezel is going to sit there, right? We'll give that a couple hours. So the board's going to sit around here. What I want to do now is get my length on this one for the battery negative. I'm gonna go a bit longer than I need because so a wire's gonna need to go from the battery negative to the switch for our voltmeter to measure the battery voltage. And so I'm gonna solder another small 28 gauge wire onto this one, cut it to length, and then solder in the through hole. I actually did the same thing to the output for the 510. You can see there. Now that thick wire to get the right bend. So the board was like this. Looks good. To mock it up, I'm going to throw a piece of double-sided tape under the board here. So we can have it sit where we want it while I measure all my other lengths. It's gonna look nice. In fact, if I don't pull it back out of there, I might just hot glue the corners down, and that tape will insulate against the bottom. Okay, the 2 greens is our switch. Let's grab these out of here. This one here is our 510. Get that soldered. Just to get our length on the 510 positive. Mentioned that I pulled this 510 out of another mod I was think it'll be easier to get the 510 on first, then I'll come clip it onto the sled. I'm gonna mount as many of the, in fact all of them, all the components onto the bezel here. I'll use hot glue to secure those down. I'll need to trim the little tabs off the voltmeter. With the box being green, that's a green voltmeter, and I'm going to grab a green LED. That's how that's gonna look. The switch I've used when I did the mock-up, I cut the pins short, and the middle pins being the in or the common on each side of this double pole switch. I've bent one of the middle leads, connected it to the, it doesn't matter which one, but connected it to one on the top here and just soldered that together. So our voltmeter minus is going to come in this side. We'll have 510 minus on one side, battery negative on the other. And you could do this with a single pole, but I had this, the double pole one, so that's what I'll use. The reason for what's going on the other side, the voltmeter actually matters in the circuit. There's a lot of resistance across the voltmeter, and if that's not there, you get unexpected results at the 510 output. So in normal mode, when the voltmeter's on measuring the 510 output, there's that resistance across the positive and negative at the output, and everything works fine. When I went to the middle position where the voltmeter was off, but the mud was still on, I wasn't getting the PWM effect. I was getting full voltage on the output. And same deal with when I was measuring battery. And my hunch is that that resistance needs to be there. And specifically, we need a resistance greater than the 10K pot. Otherwise, there's a path of less resistance, and it's not going to go through that pot and do the whole PWM thing. So I have a 15k ohm resistor, which I'll bridge against the 510 negative pin, and the other side, which is V in for the board, is going to come in there. So there'll always be a 15k resistance between the two, and I tried that on the mock-up and it seemed to work fine. So that being said, I need to wire this resistor across these two pins here, and it's pretty tiny. I'm going to bend these leads as close to the resistor as I can. I'll have to be careful when I solder the other wires on here that when I apply heat, that doesn't come undone. And this. So I'm happy with the way the voltmeter's sitting in there. I'm going to do a dab of glue between the switch and the meter. Some around the LED. Maybe epoxy would be a better thing to use. Especially for the switch, which is going to get moved around. Trying to leave a bunch of slack on the voltmeter lines here. Try and tin the leads of the LED a little bit. I cut them short, but I left the longer one longer so I can tell which is the positive. So now this, the blue wire I used, goes to the positive on the, what's it, the LED. I'm going to give myself some room here. These are super flexible, they'll tuck in there nice. So let's say
here.
okay, that pot. So the ground goes on the 0 side, and what I used for the yellow here goes on the wiper. Give myself lots of slack. So this, which is connected to ground, it's the one that's popping out of the battery negative. Go on to that same pin where we attached the ground for the LED, the negative. This last one here, which is the 510 output, it's going to go on that bottom pin there.
Be careful not to knock off that resistor.
And the last are positives. That voltmeter positive needs to be on the center pin. Otherwise, it's not connected in any position other than the bottom one there. Sorry guys, the camera died while I was wiring the button there. We've got our guts. Before we seal this up and epoxy the top portion here down, I just want to do a sanity check. Make sure this thing works. I'm gonna cheat a little bit. I've only got 2 batteries here, so I'll just jumper the middle one. And in the top position, voltmeter should measure, I'm gonna hit the fire button with my thumb, the voltage on the output. In the middle position, mod is still on, you see the LED comes on, but voltmeter's off. And bottom, we're measuring the battery voltage. You would see the sag when you hit the fire button, but so you can see how much charge you have left. And again, up top is output. With our trim resistor about halfway. Let me go down real low. So we're measuring the output, like 1 point something. Batteries, 8. So our wiring's good. And I had the voltmeter out. I wanted to... That'll be too hard to hold everything. I wanted to show the output at the 510 that when the voltmeter's off or when we're on battery mode, the output on the 510 is always what's dialed in to the pot. So the 1 point something we saw there is still what you have at the output, even when you're in those different modes with the voltmeter. Gonna get these batteries out of here and mix up some epoxy. I'm gonna epoxy the sled down a little bit under the sled. If I can. And the top piece, I printed some tabs there, so I'll epoxy onto these tabs, and then that'll sit, and I'll hold it with one of these while the epoxy's curing. Really don't need a ton under the sled. The nut on the button there is, it's kind of wedged up against it, so that's holding it in place while this cures. I throw a little drop in the corner of the sled down here.
Okay.
For those tabs. Trying to dress my wires. So we'll let that sit, and I'll be back once it's hardened. So I've waited a few hours, and that's cured enough that everything holds into place. I'm really digging the green, everything green. It turned out good that my batteries happened to be wrapped green as well. I've got the pot down fairly low, which is averaging 2 some. And keep in mind the reading, the output reading with PWM isn't 100% accurate. And I hit it just before I turned the camera on there. I suspect it's a little harder than, or a little higher than the 2 point something volts we saw, because this vape's I'd say that's probably closer to 4. Voltmeter off. Mod still works. Battery check. Mod still works. I went black button to match all the black everywhere else. So, 3 18650s in series and a Smart PWM 2.2. Thanks for watching. Catch you next time.